All right. Welcome to this next video. And in this video, we're going to be dealing with integration of exponential and logarithmic functions. So before we get to start dealing with questions of that kind, let's have a look at this particular set of information. So this information here is essential to be able to solve questions of this type. And you will see that shortly. Just a reminder, all these functions on this side are all the functions and these are the derivatives. And just as a reminder again, when we're doing the integrals, we're going in reverse. Now on your formula sheet, you are given this one over here, that the derivative of e to the x is e to the x, and the derivative of ln x is just 1 over x. So for our integrals, we'll be trying to go in the other direction. So these are the two that are given, and the other ones just come from the information you have there. So let's start with our first integral. Here we've got the integral of e to the 2x, and let's see how we do that. So we're going to be looking on this side of the table. We'll look at e, but here we've got e to some function, and it has to be the derivative of that. So you can clearly see that in order for us to integrate this, we are missing the derivative of 2 to the x. So that's what we need. So what we will then do, we will add a unit factor such that it gives us the derivative of 2x, which is 2. So what we will do for this, the unit factor we're adding is basically 2 over 2, the integral of e to the 2x dx. But what we then do with this, we simply multiply the 2, and so we're left with a half on the other side. We now have 2 to the x times 2. So the unit factor does not change the question as it is, because it is a unit factor. So as you can see now, we now have e to the 2x and the derivative of the function, which e is to the power 2. So therefore, once it's like this, it looks like this form on our formula sheet, and therefore it's quite easy for us to now integrate this. So the integral of this will just be e to the function that it is. So now we will get a half, and the integral of that becomes e to the 2x plus our constant c. So this becomes a little bit easier to do because of that fact. And let's look at the next one. So the next one over here, 2 over 3 is just a constant. So it is a constant. So this becomes the integral of 1 over x dx. And because of that, we can simply now go, this is 1 over x. If we're integrating that, it gives us the ln of absolute value of x. So this becomes 2 over 3, the ln of the absolute value of x plus our constant of integration. So these are quite important for us to be able to do, and therefore it's not that bad to do. Now let us see if we can do these next questions. See if I can lasso it and just bring it up to the top. Looks like I can't. Now let's do this one. So in here, we've got a function here. You can let this be u, as you can clearly see. But now, if you wanted to get the derivative of u, the derivative of u will just be 2. So therefore, we can see that 2 is a multiple of 4, or is a factor of 4. And therefore, we can rewrite this integral such that we've got the function 2x minus 3 and its derivative at the top. And what we'll do, we'll split 4 and write it as 2, but because the constant, we'll use it on the outside. So therefore, this becomes 2 over 2x minus 3 dx. So you can clearly see that's just the denominator is the function, and at the top is the derivative. So we now have this form where you've got a function at the bottom and you have its derivative on the top, and this is the last line now. So which means we now have to take it that way. So once we've got a function and we have its derivative there, the way we can now integrate it is to integrate it by saying this is 2, and now this is going to be the ln of the function. So therefore this becomes 2x minus 3 plus our constant of integration c. And it's quite important, if we go back, that by splitting 4 into 2 and 2, we're not changing the question, and we're just making it simpler for us to be able to apply this rule on the side. Let us now look at the last question that we've got. If you look at this last question over here, If you look at the denominator and see it as u, look at it, this is x to the 4 plus 9x. And if you were to look at its derivative will therefore be 3x to the 3 plus 9. Whereas this is not the same as the numerator that we've got here. But if we multiply the numerator by 3, it would then give us the same derivative there. So therefore, we would multiply by a unit factor of 3 over 3. And what that does, we can rewrite our integral now by multiplying the 3 inside, giving us 3x to the 3 plus 9 over x to the 4 plus 9x. And again, in this situation, you'll be happy to see that the numerator is the function u, and the denominator is the function u, and the numerator is the derivative of that. And because that is the case, we can now simply apply this rule again where we're integrating. So I've got a function, I've got its derivative, and therefore this becomes 1 over 3, the ln of the absolute value of x to the 4 plus 9x plus the constant of integration. And that is just the taste on how we do integration involving logarithms and exponential functions. I hope this has made some sense. What I'll do in the next video is do more examples. I think if we do more examples, then you've got a better understanding and better practice. I hope this has made sense, and I shall see you in the next video.